Hello there. My name is Dheeraj. I'll be discussing about logic gates because it will plays a very vital role in designing the K-maps and many other circuit devices. Also helps in implementing the Boolean operations. What are logic gates? Actually, logic gates are like some physical entities which helps us to implement the Boolean operations. They are also like an idealized, they can be an idealized concepts or as a physical devices which takes one or more than one logical input to produce a single logic output as per its functionality. It is not merely possible as a single device, but it can be developed using proper circuiting techniques. The use of these logic circuits has a very important role in multiplexer, which helps us to take 2 to the power n inputs to give n outputs, resistors, which helps us to store intermediate outputs, and arithmetic logical circuits, which helps us to do the arithmetic calculations and also in the computer memory. All the way, we also end up with the using of proper microprocessors that helps us to store or has thousands and millions of gates. Logic circuits helps us to deal with the manipulation and the processing of the binary information. Logic gates have a very important role in making or manipulating the processing devices. Its functionality is been described in a truth table. A truth table helps us to understand the input-output relationships of the logical gate. So, let's have some brief explanation about different types of logic gates. The first operator is called the OR operator. OR operator is used when there are two inputs, as we know it is in a logic gate, which gives true when either of A or B is true. Or simply we can say that it is true when either A and B are true. Its symbol is given with a dome shape and just a concave structure. As we can see here, it is when A is 0 or B is 1. The resultant is 1, as you said, either of A or B. So let's get to next one. AND operator. AND is also another type of logical gate which displaces the output only when both A and B are true. The physical representation of this LAND gate is a straight line with two inputs and one output. As we can see here, that only when two A and B are 1, we get the output 1. The Boolean expression is A into B. The next one is inverter or NOT gate. Inverter or NOT gate is only true when the input is not true. We represent it in this way: a small circle at the output sector and dashes, which implies it gives an opposite signal of the inputting signal, 0, 1, 0, 1. In the expression, we write it as A bar, which means to give the opposite of the original value. Next is the exclusive OR XOR gate. This is a very interesting thing because it is the same as any other, but it works at a very different way. The physical symbol of this is with a double concave structure and one single output and a double input. Now the output Q is true only when either of A or B are true. When both of them are giving the true, it becomes a false. Let's see here. See here, the A is 0, B is 1. Then only we are having 1. A is 1, B is 0. We are having 1. But when both of them are 1, we are getting the output as 0. NAND gate. NAND gate can also be pronounced as AND followed by a NOT gate. So the physical symbol would be an AND gate with a small circle at the starting. So it would be the same, but will be having an opposite functionality as same of the AND. In AND, if you remember, we said that only when A and B are true, we get the output as true. But when you see here, except at A true and B true, All of them are having the 1, means the opposite functionality of the AND gate. Next is NOR gate. NOR gate is the same as NAND gate, which is F all followed by a NOT gate. For n input, the output Q is true if both input A and input B are not true. So if you remember, in OR gate I have said that only when A and B are not true, we are getting the Q is not true. So at the same case here, when A and B are not true, inverse case here, we are getting Q is true. Next is the exclusive NOR gate. It's the same XOR gate with the NOT symbol ahead of it. The same NOR symbol, the XOR symbol, and starting we are having a circle. So at the very same way it behaves the same, but in the contrary behavior. So in NOR we have said that if either of A or B are true, then we are getting the output as true. But when both input and output are the same, or if both input and output behave the same way, then we are getting a true. So A and B are false, having the same characteristics, then it is true. But when both of them are having the true, then it's also having the true. Let's have a quick summary. Here we are taking the inputs and we're describing about the different table outputs. And one displays when both of them are true. NAND, which displays 0 when both of them are true, or which displays true when at least one of them is 1, NOR, which displays 0 when at least one of them is 1, XOR, which displays 1 when at least one of them, when only one of them is 1, XOR, which displays 0 when at least one of them is 1. And a very important point in the logic gates, the AND and the NOR. These both gates are known as universal gates because they help in designing and in making many other gates using the famous De Morgan's law. Thank you.